You know, predicting the future is a lot like guessing the weather. If you only look at yesterday's temperature, the numbers, you miss the big picture. You need to look at the calendar to see if it's winter, and you need to read the report to see if a storm is coming. That's what we call multimodal data. The problem is, most current machines are bad at listening to all these signals at once. They just glue the text to the numbers, which is clumsy. UniDiff treats the numbers, the text, and the time as equal partners in a conversation. Let's look at how people usually build these things. In A, the model is driving with one eye open, looking only at the numbers. In B, they just tape the text to the numbers, concatenation, which doesn't really let the data mix. In C, they try to turn the numbers into words for a large language model, but you lose precision that way. Now look at D. This is UniDiff. We don't force the data into a line. We process the text, the time, and the series in parallel, letting them interact right from the start. It's a much more natural way to handle information. Here is the machinery. We have 3 inputs entering separate doors: the text, the number sequence, and the timestamp. They don't wait in line. They go into this multimodal fusion circle in the middle. This is where the magic happens. It's a parallel mixer. Then, look at the right side. That's the diffusion model. It takes a block of noise and sculptures it into a prediction, guided by that mixed information we just created. It iterates, step by step, refining the shape until it matches the future. So, how does the machine actually think? First, we chop the time series into little patches, so we don't lose the local details. Then, instead of saying, look at the text, then the time, we use a single cross-attention mechanism. It allows the model to look at everything at once. We also added something clever called decoupled guidance. Imagine you have 2 volume knobs, one for the text and one for the timestamps. If the text is noisy, we can turn it down. This gives us control that other models simply don't have. We didn't just write equations, we tested this in the real world. We ran it on 8 different environments: agriculture, energy, health, you name it. The results? It beats the big, heavy LLM models and the simple statistical ones. And look at the efficiency. It doesn't need a supercomputer to run. The most interesting part is when we broke it. We took away the text, and the error shot up. That proves the machine isn't guessing. It's actually reading the news to help make its prediction. Look at these heat maps. This is the brain of the model lighting up. On the left, in A, there's a sudden flu outbreak. The model ignores the calendar and stares right at the text about outpatient visits. It knows something unusual is happening. On the right, in C, things are normal and seasonal. The model ignores the text and looks at the timestamp. It knows it's just flu season. It autonomously decides which signal matters more in the moment. So, what's the takeaway? You cannot just mash data together and hope for the best. You need a system that lets the data talk to each other freely. UniDiff does exactly that. It takes the noise, listens to the text and time signals without bias, and gives you a clear picture of the future. It's elegant, it's efficient, and it might just be a harbinger of things to come.